Now I'm going to finish this lecture by introducing an illustrative example of the popular CSU2 SAMP that we considered in example 2. So this is sampling design is essentially we had example 2, which is the two-stage sampling with equal probability. I mean the PPS stage 1 and equal sample size in stage 2. So this example is actually very similar to the one introduced at the end of week 14 lecture, but now we allow that MIs are all are different from clusters to cluster. So since MIs are unequal, it makes sense to select sample clusters using the draw probability proportional to MI in the stage 1, and then stage 2 we use a same sample size. And then the second part, the last part is the same as before. So we from the sample household, we obtain two information. One is the number of household members in the house, and the other one is the number of household members with age under less than 6. So this is the data set, and this data set is actually the same data set that we used in lecture 14 lecture, but the sampling design is different. Now, to estimate the proportion P, we use the ratio method. Note that P hat. So this is the ratio of the P is the ratio of the two population totals. So we just use their estimate, and that turns out to be, and this is actually in this sampling design, we have an equal weight. So basically, it's just the sample mean of y divided by sample mean of x. Okay. For variance estimation, so we would use the simple formula. So this is essentially PPS2, right? So y hat PPS, t hat PPS2 sampling variance is actually 1 over n as z squared. So we're going to use this formula, but because this is a ratio, we need to do linearization. So we use the linearization itself is the same as week 14 lecture. So the answer should be x bar u and then y bar pps 2 minus p x bar pps 2. So that because we can write it as a y pps2 t hat x pps2, but we can also divide by both sides 1 over n, then it becomes y bar pps2, and then this is x bar pps2. So same thing. And so we just use the same formula, the Taylor expansion formula, to obtain that p hat is actually equal to 1 over x bar pps, so estimator square of, and then the variance of the this guy. Cool. So that means we can use this. We know how to do this, right? I mean, we know how to compute this variance using this SSE square. So now here we use this one. So basically, this guy is actually, so this variance equal to 1 over n minus 1, and then y bar I minus y bar k minus p hat x bar k square. So that's exactly this part, and this part. Okay, and then this is the x bar pps 2. So that provides the gives the variance estimation for OP head. So okay, so that's all for lecture for this final that week's lecture. And I'd like to thank you very much for your attention during the class, and I hope you guys all stay safe and healthy. Bye.